Thanks for coming. My name is Jim Cummins. This is Getting Started with Angular 2 and Typescript. Angular 2 is a web framework for building large-scale applications. It's created by Google, and Angular 2 is the second iteration of that software. It is a complete rewrite, so it doesn't share code with the original Angular 1 code base. TypeScript is a language that has been created by Microsoft. Google has written Angular 2 in TypeScript so that they can utilize a lot of the features in TypeScript. TypeScript's actually been around for between 4 and 5 years, but it's really starting to mature now. And Angular 2, it originally wasn't written in TypeScript, and Google actually was so excited by these features, they rewrote Angular 2 in TypeScript specifically so they could use a lot of these features. So again, my name is Jim, and I'm a developer at FizzDApp. I'm also the author of an open source package called Commitizen, which allows you as an open source maintainer to set up rules for people who want to commit software, to commit code to your software. It allows you to set up rules so that you can basically maintain a really clean code base and have exactly the information you need in your commit messages so that you can generate a change log automatically. Open source has a special place in my heart because I am a college dropout, and the only reason that I would be speaking here in front of you today is if there was open source so that I could go in and look at all of the things that people had done before so that I could learn from them, so that I could interact with the community, because the community of open source is definitely much more powerful than the actual code itself. The number of people who have given me 5 minutes over the years to answer my question or to have a conversation with me about how to structure my app is just invaluable, and so I would encourage everyone here to get involved in any way possible, whether that's giving feedback or asking questions. Open source is about collaboration, so definitely continue to get involved as much as possible. So let's dig in. I'm going to give you a little bit of an intro here on why Angular 2 is written and what problem we're trying to solve today. One of the things that we want to dive into then after that is the actual TypeScript language so that the code doesn't look quite so foreign when we get to Angular 2. We're actually going to build an application using Angular 2, just a small one, and then there will be some time for Q&A after that. Excuse me. The things that we're not going to cover today are Angular 1 to 2 migrations. There's a lot of Angular 1 apps already out there. We don't actually want to go into how you would migrate those, but there are already some presentations out there that are hour-long presentations on how you might do this. There are some best practices you can follow, and I would encourage you to reach out to me if you'd like some of those resources. We're not going to talk about Angular 2 animations or Angular 2's internationalization library, because those are both currently under development, so I can't actually talk about them. Angular 2, that brings up that Angular 2 is actually still in active development. This is alpha software. You should not be using this in production today, but it is something that if you know the concepts of, you can actually start writing your applications, whether they're Angular applications or not, to use some of the features that we're going to look at today. And we're going to talk about that theory in this first introduction. So let's go back to 1996 when the web really started to kind of take off, and we were all creating documents with the web. We weren't creating applications. We were creating pretty much static content. Maybe there was a little bit of interactivity, but pretty much we were writing documents, and that was what the web was written for, and HTML was really geared towards. So in this scenario, let's look at this little kind of component that we have here, where we have a list of people, and each person has their own person tag. Now this is HTML5, obviously not 1996 code, but now we can write this. We can write custom elements just like this in our code, which is great because it has a lot more meaning than if we just use divs everywhere. This is easy if you're a developer to say, what am I actually looking at? What am I working with? And then we have this CSS selector. And what this does is it says, if I have the selected attribute on a person, go ahead and make that bold. So really simple here, really simple CSS. This is what we are writing, and this is what the output is. So we have Jim and Mira, that's me and my wife, who are not bolded, and then my daughter, because she is selected, has bold. So this is pretty straightforward HTML CSS. let's fast forward a little bit. Say we're working in the exact same page, so that code that we just saw is still in the page, but of course now we're building an application. Maybe it's a dashboard, something like that. So we're going to add some more code to it. Here's some code we want to write. This looks really nice. It's a really straightforward API. We can write HTML where pets are a list, and then each pet has its own tag, which is pet. Again, we're using selected because it's really clear. It's showing that this is the selected pet in our output. And we're also going to use CSS again in this component. And this time we're going to say text decoration is equals underline. Now you'll notice that we use the exact same CSS selector. We use the brackets with selected. And what that does is it actually introduces a problem. You'll see the problem here. Shanti is bolded and underlined. Now remember, because we have the same code that we had before in the page, we actually have two CSS styles in the page, both use selected, and this is a problem. Now we could fix this problem, and often we do, by writing, instead of selected, we might write a more specific CSS selector like pet selected or person selected. But now what that means is that we're changing the way we write code because the language doesn't do what we want it to do. And what we really want the language to do is encapsulate each of our components so that they don't bleed into the other components, and then we don't get unintended side effects. And so one of the great things about CSS, but also the bad thing about CSS, is that CSS rules are global, right? We can't scope CSS rules. They're just there. And in order to encapsulate them, we just have to make them super specific. And then it begs the question, how reusable are super specific selectors? Well, they turn out to be not very, very reusable. We end up copying and pasting the selector over and over again, right? So we need encapsulation. And thankfully, the web is coming out now with something called web components. Web components give us this encapsulation that we want so that we could create a component like this without having selected bleed over into other components we might be writing. And what this lets us do is it lets us write code like we want to write code, not like we have to write code. And so this is really important as we go forward looking at Angular 2. Angular 2 is built using web components, but remember, web components are just a technology in the browser. They're not actually a way of building applications. So we need a way to say, how do we build applications using this component infrastructure? Now, you may already be using components as a way of building your application, but you're probably not using web components. If you use Angular 2, then you'll be using web components. You don't need to think about that, but you still need to think about components. So when we talk about components the rest of this presentation, forget web components for now. Just think about components as a way to build your application. So let's again look at our applications of today. Applications of today can tend to be a little bit of a rat's nest. We might have an app that includes things like person, people list, pet. These are just examples. They don't really mean anything. And then we trigger events when we interact with them. And those events cause different data to be displayed on the page at different times. And so our data flows in the opposite direction of the events. If I click on something, say I'm looking at a list, and I click on a filter, well, I clicked, that was the event on the filter, and the data that then goes into the list is the data. Now I have a two-way interaction there. I have the event, which is the event being clicked on, and then I have the data going the other way. And so we're going to represent these just as arrows. Hear me out. The events are in red, the data is in blue. So this is kind of how it looks, and as we develop our application, we get more and more complex functionality. We get data flowing over here and events flowing over here, and it kind of becomes unwieldy. We get that we can have this happen where we click somewhere on the page, and then some data happens, which triggers an event, which causes data to happen, which causes an event. And Angular 1 and some other frameworks try to prevent you from doing this, but it's easy to have happen where you say, well, why did that change? I didn't do anything with that. If you've written a function called init, then you know what I'm talking about, because you will call init and someone else also called their function init, and now we have this kind of churning aspect to our application. So how do we do better than this? Well, we can start to think about our applications as just a tree of components, right? At the top we have our app, and then maybe we have some lists that exist in our app, And then underneath that, each item in the list is of a specific type. So this kind of lines up with the components that we started to write in those initial slides where we were looking at our components. How does this look with events? Well, events flow up. So if I click on a person, that tells the person list that I just clicked on that person. So the person list would then define whether or not I want the data to change in the list. Or maybe I want to show a completely different page in my application, in which case when I click on person, the event flows up all the way to app, and then app says, okay, you clicked on a person, now maybe we want to show that person's pet list. So I clicked on person, and now the data in the app up at the app level is going to say, okay, don't show person list anymore, show pet list. And this is how our data goes. Remember, it goes the opposite direction. There's no way to get around this. But what's great about this is our data is all flowing from the top down, and we're filtering bits of the data out based on where we are in the tree. So by the time we get to person, all we have is a single person. But if we're in person list, the data is a bunch of different people. And the same goes for pet list here. And as we add things to our application, functionality to our application, it doesn't matter because our arrows still all line up. So we're not actually adding, we're not going to have this circular dependency tree, which we end up with in a lot of applications, which causes really big headaches and makes it really hard to understand. So again, the data is flowing in one direction. Happy face, that's great. All right, so we've covered a little bit of the component layout that we want to get to, but we haven't talked about JavaScript, and we haven't talked about TypeScript and what the differences are, because a lot of us know JavaScript, and we might say, well, I don't really want to learn another language, that's not really something I'm interested in, I'm so used to JavaScript, why would I change now? The great news is if you know JavaScript, you already know TypeScript, because JavaScript and TypeScript are very, very close to each other. The only difference is that TypeScript, we add types into JavaScript. Now, what do I mean by types? Well, if you've heard of Java, Java is a strongly typed language, which means that when we create a variable, we say what type of thing we're going to be putting in that variable. We might say, here's a variable called name, and that variable name is always going to have a string in it. I can't later put an integer in there. So it's very strongly typed. JavaScript is the exact opposite. We just say variable name equals whatever, and if I want to put an integer in there, I can put an integer. If I want to put an object, I can put an object, and I can change it over and over and over again. So TypeScript is somewhere in the middle here. It's called duck typing, which means that you can use types if you want. You can use types if you don't want. It is whatever you want. But the more that you use the types, the more you're going to get back from your tools. So we'll talk a bit about what that looks like. But bottom line is, if you want to use TypeScript, you can just take your files, rename them to .ts, and they are now valid TypeScript. You might not get anything back from them. You might not get any benefit, but it certainly is not going to hurt. So this is also called humble typing. If you hear that, it just means you can use it when you want to. So again, why are we using this? Well, we might want to use TypeScript because in large code bases, you're going to get better readability. So if you're a developer who hasn't worked in this area of the application, it's a really large application, you sit down, you open the file, you know there's a bug in the file, you know there's some bug happening, but you don't really know about what data is flowing in and what data is flowing out, right? Well, TypeScript allows you to basically know what the developers before you expected from this component. And so this is really powerful when you're just sitting down needing to work on this. Also, you get a lot easier refactoring because if we know that this function assumes there's a string coming in, then we don't need to do type checking on it if the editor already says we know a string is coming in. Another nice benefit of this is there's new language features in JavaScript, and TypeScript lets us use those in current browsers for free. So there's something called classes we'll look at. You can use classes in TypeScript, and it will convert them down into JavaScript that just runs in the browser for free. So you get to use these new features, which is great. The last thing, and I think this maybe is my personal favorite, coolest thing, is you actually get auto-suggest, like IntelliSense. So if you've ever programmed in Java, or in C#, you know that we get this because we're using strong types. Well, TypeScript gives us the ability to actually start typing something, and then our editor is going to say, hey, do you want to use this? Do you want to use this method? Do you want to use this property? And we can just hit enter and it will autofill it and actually ask us for the fields that we need to fill in. So it speeds up your development time too. In addition to, if there's many different properties, you can just start typing the first 3 letters and you don't have to worry about all of the other properties that might be there that you're not interested in. So again, I said that if you know JavaScript, then you know TypeScript. What does that look like? It looks like this. JavaScript is a language that is getting these new features, and if you're using JavaScript, you can essentially just start using these TypeScript features, and as you add to your source code, you're going to get more and more benefit. So what is TypeScript actually doing though? Well, TypeScript is compiling your TypeScript to JavaScript, and the benefit of this is it will show errors if you have, a missing semicolon, whatever. It's going to tell you right then. You don't need to go into the browser's console. You're going to get feedback right in your console if you have that open. And also, obviously, it helps the editors to analyze the code. So there's 2 pieces. There's a compiler, and then there's a server, a little tiny server that runs on your computer when you have your editor open that analyzes your code. And that gets us all of those IntelliSense features that we were looking at. So let's dive in. I mean, we haven't really shown what TypeScript looks like. In this case, this is a Hello World application, but I'm going to use my daughter's name because I'm a new dad. So what does this look like in JavaScript? Well, JavaScript, very simple. Again, we can see here that the variable name does not have a type, so that's what we were talking about. No type. We could change the name to the word 5 or the integer 500 if we're dealing with a robot, and it would be perfectly acceptable. It spits out hello Annabelle. So here's what it looks like in TypeScript, and maybe you can spot the difference. Very small. All we do is we put a colon and then the type after the variable. And what this does is it lets us create the variable. We can use it just the same as we did, except this time we've identified this as it should be a string. And so if we were to try to, later in our code, change this to the number 500, our editor would say, you can't do that. Go back and try again. What this is also going to do is, when we talked about the compiler piece, TypeScript compiler is going to take the above code and convert it into the exact same code we would have written if we weren't using types. So if you do view source, you're going to actually see the JavaScript that we see on the bottom there. And TypeScript has source mapping. So if you enable that for your development workflow, you can actually get it to show you in your browser the top code, even though it's interpreting the bottom code. So it's really cool. It takes you right to the line where you have a problem. I talked about classes before. Now, we said one of the benefits of TypeScript is you get to use these sweet new features that are in JavaScript in the browser right now. So this in itself, the code we're seeing on the left here, doesn't actually use any TypeScript features. It's just JavaScript, the new version of JavaScript, right? We have a class. All the class does is it greets. So if we call the greet function, it returns the name of the person. Really simple. Here it is in TypeScript. So there's a couple changes here that we've made. First of all, we've said that the name is public, and so if we were typing in our IDE and we started typing person dot, we would be able to see person.name because we've said public. If we said private, we wouldn't be able to see it. So this is something that's actually not in JavaScript. In JavaScript, everything is public. TypeScript gives us this encapsulation if we want it. Then this is the exact same example that we saw before, where we're telling it that name is of type string. Now this is a little bit different. In this example, what we're saying is the greet method should always return to us a string. If a developer came in the future and changed the return line right under this to return an object, they would get an error, and it would say, hey, all the other functions that are relying upon this expect you to return a string. You really should be returning a string. or you need to change the type. But then what that's going to do is you're going to need to go refactor those other functions. So we talked about the ability to refactor. This is one of those benefits where we could actually click on the greet method and do find occurrences, and it would essentially tell us all the places that the greet method is used. So really powerful stuff there. Interfaces, maybe a little bit more of an advanced topic, but interesting nonetheless. TypeScript gives us this for free, which is great. Basically, you would want to use an interface, and we generally want to use interfaces to define functionality. So we want to try and write our code as best we can to use interfaces that use a functionality. And in this case, we're gonna look at if we wanted to have multiple things be able to greet, right? So like we talked about, a robot can greet and also a human can greet, but they might be greeting in different ways. A human is going to say their name, a robot might say their ID number, which is an integer. So what does this look like? Here's TypeScript again. All we do is we define an interface up top, and in that interface, we're essentially defining a contract that says, if you are going to use this interface, that means that you will define the greet method somewhere in your class. And we can see down below, person has a greet method, so that's great. That means this class is properly implementing this. If for some reason a developer came and deleted the greet method because they said, well, we don't use that anymore, well, then they're going to get an error saying this class is no longer valid. You said you were going to define this interface, and you no longer do. So that's what this does. And in order to actually implement the greets interface, we just say implements greets. If you've used Java or PHP or C#, you already know about this functionality. But what this does is it essentially allows us to say, look, the robot is using ID. It's not using name. But we don't care, because all we care about is that the thing that's getting passed down below has a greet method on it. So if you want to be a greeter, you have to be able to greet, right? So let's talk a little bit about modules. Modules look like this. Person.ts, we've been looking at this already. Really simple stuff. All it does is greet. The thing about TypeScript that is different from JavaScript in terms of your files, if you include a file into your HTML file in JavaScript, you add a script tag, that code is going to be automatically run, and it's going to be global. So if I have two files, those files can interact without me needing to do anything. This seems like a great feature, but when you get larger and larger applications, you have more and more problems. And so TypeScript and Angular, by extension, will by default encapsulate it on a per file basis, so that if we define a class, we can't actually use that class in another file unless we explicitly import it. So this is powerful because it makes sure that we are going to know exactly what is imported into our file, so that when we go to refactor, we don't have to kind of guess where did this come from. So let's look at what this looks like. This is actually an error state right here. If we are in if we're running our application, app.ts is saying, give me a new person, and that person should be Annabelle. But our TypeScript is going to say, whoa, I don't know what you want me to do. I don't know what person is. Person is defined another class, and you haven't told me where to find that. So we're going to do this. We're going to import person from wherever the person file is. Now you'll note that I left off .ts. That's because it's assumed. You could put it on there, and it would work, but for now we're just going to assume we don't need it. And if there were multiple things that I was importing from that file, I could just comma separate them: person, people, pets, etc. Now this actually does yield another error state though, right? This doesn't fix our problem exactly, because it's saying that the person file has no export person. Actually, this is wrong. That shouldn't be there for that. But you can see, once we add the export in, now what we're saying is this should be available from the outside. And so now we have a success. And this is great. I mean, we've achieved encapsulation on a per module basis. We know exactly what our dependencies are for every file. With a little more code, but it's very clear. So how do I use TypeScript? Install Git if you don't already have it. Install Node.js. Just go to nodejs.com/download, and it's straightforward install. If you have any terminal or console windows open, close those and then reopen them after you've done this. And then you can run npm install -g, TypeScript, and TSD. If you're on a Mac, put sudo in front of that, and it'll ask you to type in your password. What that's going to do is it's going to install Typescript, so that's the Typescript compiler and any editor tools you need. TSD is a second package, so this is actually installing two packages. TSD stands for TypeScript definitions. All that is if you want to use, say, jQuery, which is written not in TypeScript but in JavaScript, you can actually use it and still get the benefits of TypeScript because the community out there has written TypeScript definitions that essentially emulate TypeScript's benefits. So they've said, you know what, in jQuery, whenever you do $ and then put a bracket, you need to then put a string. And so what this does is you can actually use non-TypeScript things in TypeScript and get the benefits because the community out there has done this. And you would just type something like tsd install jQuery, and that will install the definitions for jQuery. So we're not going to go too much into that. It's probably more an advanced topic, but you can do it. And when you're installing, you should just install both. So which editors support TypeScript? Here's a couple. Adobe Brackets, GitHub Atom, Sublime Text, any of the JetBrains editors, PHP Storm, WebStorm. They all have plugins or they have native functionality. JetBrains editors have native. Everything else requires a plugin, but really pretty good support. Microsoft actually writes the Sublime Text plugin, so it's pretty good. Atom has a great plugin too. I haven't used the Brackets one. The one that I want to call out is Microsoft Visual Studio Code, which is surprisingly good for a Microsoft product. It runs on Linux, Mac, and on Windows, and it's actually written in TypeScript. So it runs in like a regular program, but it's written in TypeScript. Really cool, great functionality because TypeScript is written by Microsoft, and it's written in TypeScript, so it's always going to have the most up-to-date features that you want, and pretty enjoyable developer experience. How do I use it? Well, you can use any of these different methods. There's multiple ways to use it, but essentially you can use it on the command line just by typing TypeScript, passing it some arguments. I'm not going to go into it here, but all you need to do is say, I have these TypeScript files, I want them to be JavaScript files, put them here. You run a command, it converts them. Simple. If you have an IDE or an editor, a lot of them have it built in where you can actually have it so when you save a file, it automatically outputs the TypeScript or the JavaScript. If you have a Gult or a Grunt, some projects will have a task runner that runs and does a bunch of different stuff. There's plugins for that, so if you have like a more complex setup, you can integrate it there. And if you're on the cutting edge of web technologies and you're using something like Webpack or JSPM, those are two kind of more advanced setups, but you can also use those. There's great plugin support there. Awesome. So let's talk about Angular2 and what it means. Well, I'm really going to focus on how to build an Angular2 app and what the positive things it encourages are. There's a lot of advanced technology that you can get into. There's things like pipes. There's things like services. There's all these additional things. Once we go through this, feel free to go and learn those things. But I really want to focus on how do we build a component? How do we start, right? We start with a class. All we do is we write export class person, just like we saw before. Here we haven't defined any functionality, but this is the start. Then what we're going to do is we're going to import component from Angular2's project. So here we're just saying, I need component from Angular2. And we're going to add it down here. You can see it looks like an annotation because it has that @ symbol in front of it. All that means is that it's metadata. So it's not actually functionality. It's just data that we need to know about a component for it to be a component. So in this case, we're saying the selector for this component is person. If you wanted to, you could have the class be person and the selector be people. I don't know why you'd want to do that, but possible. So you might have a selector like person, and then when you actually go to use it, all you have to do is create a new tag that says person. So the selector corresponds to what the tag is going to look like if you go to use it in another component. And we'll look at what that looks like later. Again, people list would yield the element people-list. So pretty straightforward. So the component gave us a selector so that we could use it, and the class gave us a place to put functionality, but the component doesn't have any, it doesn't look like anything yet in our page. So how do we do that? Well, We import view, because again, we import everything that we need. Everything is very clearly defined at the top of the file to say what we're actually using. And in view, we can just pass in an object that has a template. And in this case, we're going to say a person has hair and has eyes. So really simple. Hopefully they have more things, but we'll start out with that. And then we want to style it a bit. So in this case, we're going to say they have 150 pixels of hair, which I don't know what that is, but it's some hair. And then their eyes are round. So border radius 50% gives you round eyes. There you go. We've got some styles. So hard to see where this is going yet, but this is our first component. We have a component here. We could go and use this elsewhere. And like we saw before, all we would need to do is use a person tag in another component. So what do we gain from doing this? Let's just review. We got explicit dependencies. We have a very clear external API. How do we use this? All I need to do is use a person tag. We have an internal structure that is composed of other components, hair and eyes. And we have the ability to visually style our children from the parent. I don't know why that's messed up, but a place to define, and we also have a place to define internal functionality. So we haven't defined greet here, but that's just because the slide gets too long. We could put a greet method in here, and then somewhere in our code we could call it. And we'll see what that looks like later, but I'm going to leave it off for now. We just wanted to define our first component. But wait a minute, I lied. I said one of the benefits of components is that we get an internal structure composed of other components, and hair and eyes are being used, but I didn't import them, so they're not actually components yet. That's not actually true. All they are HTML tags. So one thing you can do in Angular 2 is you can just use HTML tags. The strong tag, which makes things bold, you can use it in here. It will make things bold. So how do we actually make these into components? Well, all we need to do, or how do we use these as if they were components? All we need to do is say import some child components, specifically the hair component from this file, which is just a file that we'll create in the future that holds a very similar structure to this, and import the eyes component. Once we've imported them, we need to tell Angular about them. We're going to use this special object called directives, and we're going to pass in any of the components that we're going to actually use. What this does, again, is it makes sure that we're very explicit about what we're actually using. This is super important. But I have failed because in this example, I put square brackets in HTML. And I know there's probably a lot of people that are saying, that is not valid HTML, what are you doing? You're crazy. But actually, Angular 2 uses this, and it is valid. Even though the validator might choke on it, it actually, per the spec, is valid. And what Angular is doing here is they're saying, this is how I pass data into other components. So remember back to our blue arrows, right? Our blue arrows always point down. So we are at the person level, and we're saying, here's the data that I'm passing down into my hair and eyes. So in this case, our hair is black, and our eyes are brown. So just to review, here's what our setup looked like. I've changed it a little bit here, so we have an app component, which we're not looking at, but we're starting with a person, and then we have hair and eyes. And so what we saw before with the square brackets was those blue arrows, right? So here's our square brackets, and those represent those two blue arrows. And here we're passing in a string of black and a string of brown, but we could also pass in a variable. If we had a variable that was eye color and hair color, we could put those in there without the little single quotes, and the value of those variables would be passed in. So we don't have to use static strings. We can actually start to take data, break pieces out, and pass it down into the component tree. That's how data gets passed down through these components. But how do we handle user interaction, right? We haven't talked about the red arrows at all. So what does that look like? Well, an interaction from the user in some case, or in some way, will trigger an event. And events use, again, really strange notation, but they use parentheses. So this is actually valid. What we're saying here is that when the blink event is triggered from the eyes component, I want to run the blinked method in the current class. So we'll look at what this means, but essentially what we're saying is when an eye blinks, run the blinked method and log out the eye color that was passed back from the event. Okay? And so here we're really just handling an event from any of our children. We could do the same thing for hair if someone got a haircut, and so we had an event in the hair component called cut. When that hair gets cut, then we could have a haircut function here that gets called. And so what we're doing is we're starting to see where those red arrows are coming from. Where are the red arrows coming from? So again, events flow up. If we blink, if our eye blinks, then the blinked event gets called. That's that red arrow right there. Now we didn't define any events for hair, so you notice I didn't put a red arrow there because we don't actually have an event for eye or for hair. But if we had a cut, we would add a second red arrow and we would add another event right there. But how does that actually happen? So there is no blink, right? But let's say that in our app, when a user clicks on the eyes, that is essentially blinking, right? So first we need to detect a click. How do we do that? Well, Angular has a built-in click event that you can put anywhere. And that, by detecting that click event, so now here we're in actually eyes. So we haven't looked at this file yet, but this is the component eyes. It looks very similar to the person component. There's a couple differences, but fundamentally, our template says we have two eyes, and each has a click event on them that we're looking at. And when that click event happens, call blink and pass in the color. But where does blink come from, and where does color come from, right? Well, it comes up from up top. In the component definition, what we're saying is, I, as a component, emit the event's blink. So any parent component can listen for that event and then do things. And also, we have a property, and the property is color. Remember, in our definition, when we were in person and we had an eyes tag, we passed in the color. So what this is saying is, I expect data to be passed into me as the eyes of a color. And that's where those two come from. So I can just use those below in my template to essentially call the event on my parent that's coming in. And that's all. You just created your first component, and there's nothing else that you need to know for now.
Right. I have a question about eyes.
Yeah.
So if you go back,
Yeah.
the class is eyes.
Yep.
And it's in the folder eyes.components.ts. If you go back to where we're importing into the person parent,
Mm-hmm. It's way up here.
Right here.
Right here.
It says eyes component.
Yep.
Is that so the directives, that's a way that Angular understands how things are written out?
It's a good question. It's actually not.
Okay.
It's a convention for file name.
Convention, that's the word
Yeah.
I was looking for.
Yeah, it's a convention. So in this case, we're only dealing with components.
Okay.
But like I said, there's also something called pipes. There's something called services. Services are the way that you get data from the server. So you might go out and hit your API, and services do that. And the reason we do this is actually because we want to structure our applications in a way where we're designing by feature,
Right.
not by type of file.
Right.
But in some cases, you may want to do something to only components.
Mm-hmm.
So if you put .component in the file name, then you can still find all of the components, even though you're using this structure where there's not like a components folder.
Sure.
So maybe like services, you might want to do something, you might be specifically for testing.
Mm-hmm.
It's helpful to be able to load up all your services or all your components, because then you can have your whole component tree, but you don't have a components folder.
Okay.
So it's not like in JavaScript where we typically see like a JS folder.
Mm-hmm.
It's very much more like we have a source folder, and then in source we have people and pets,
Right.
and then in there we don't have folders, we just have files, and each one has that component. component or .service.
So that class name there where it says import eyes component, that class name is just a convention that it uses to get that
Oh,
class name from.
I see what you're saying. Yes, you are right. This is a bug
Oh,
in my code.
Okay.
Yeah, so down here, thank you. That's awesome. This is why I love having other people watch. Yes, this should be eyes component.
That should be class
Right
eyes
there.
component. Right.
Thank you.
Okay. So
Perfect.
then when you bring it in, when you're importing the class. No, I thought maybe it just added on the extra component part
Nope.
because it knows from the file name
Nope.
that it.
Total bug.
Okay.
Yay!
Awesome. Yay!